And welcome to space and the weather therein. Could be an exciting day for space weather today. We'll get to it. We'll talk about what's going on with the sun, what's likely to continue to go on with the sun, what's on the way to Earth, able to strike Earth at any moment, and lots more here at the Smash News Network, least busted name of news. This is the past 24 hours from the Solar Dynamics Observatory. It's the AIA instrument, which depicts extreme ultraviolet light in the wavelengths of 193 plus 304 angstroms ionized iron and helium. You may see one M-class solar flare happening in the southern hemisphere. We'll cover that in great detail as well. There was also a CME, which we will also show. So let's break it down here with some closer views. There is your equatorial zoom. Let's take a look at some specific quadrants. First of all, that M4 approximately class flare came from down here. There's a new sunspot that grew just to its south. Also another sunspot in the northeast. Also the coronal hole at the north heliographic pole has left the north heliographic pole and moved down toward the equator. We'll show that as well. So lots to talk about on today's daily space weather video. We've also got a solar polar vortex going on up here at the northern polar region. So a coronal hole has lurched down toward the equator, and you can see crown prominences up there. Huge filaments of plasma there encircling the north heliographic pole. It's exciting stuff. And there was a CME that came from this area right over here. You can also see a secondary Hyder flare happening. That's that brightening happening right there. As some of that plasma did not make it out of the corona, it splashed back down toward the chromosphere. So don't worry, we've got a lot more to show you here. In fact, let's briefly take a look at sunspots. Again, we do have a new sunspot region that formed down here. That's a beta gamma class sunspot already. Also a beta gamma class sunspot formed up here. And this huge sunspot that just rose in the southeast indeed does have a trailing North Pole umbra, making it beta gamma class, thereby increasing the likelihood of solar flare activity. Now, that's your colorized magnetogram, also from SDO. That depicts yesterday plus today. Also a little bit of growth in this sunspot group down here, and a little bit of growth up here as well. So little minor uptick in solar activity, and we are looking for an uptick in space weather. Also a possible uptick in volcanism coming. From where, you might wonder? Well, from Fagradalsfjall, yes, on the Reykjanes Peninsula, Fagradalsfjall. So while the seismic activity has ceased here in the past several hours, the 2021 and 2022 eruptions were both preceded by a calm before the eruptive storm. So this map depicts ground deformation. You can see quite a bit of ground deformation happening there beneath Fagradalsfjall on the Reykjanes Peninsula, Iceland. And thousands of earthquakes have been detected. Again, those have calmed down now. However, the 2021 and 2022 eruptions were both preceded by a ceasing of activity here. So there could be a new eruption about to happen at Fagradalsfjall. Popocatépetl exploding in central Mexico. That's producing a 22,000-foot ash plume. 14,000-foot ash plume over Guatemala from Santiaguito. No recent emissions observed from Fuego in that same nation. Nevado del Ruiz in Colombia exploding, flight level 200. It's a 20,000-foot ash plume from Nevado del Ruiz. Revenador exploding, flight level 140 over Ecuador, flight level 200 over Peru from Sabancaya. Not sure about Ubinas. Don't assume it's not erupting. Let's take a look at seismicity next. Here are the past 90 days. And it's been 48 hours of pretty calm conditions as far as seismicity goes. Here we will cite quakes of a 5 magnitude or higher. So this is the USGS list. There was a 5.3 at Indonesia yesterday at 17:13 Universal Time. There was a 5.5 at Papua New Guinea at 20:04 Universal Time. Moving into today, no 5+ magnitude quakes, so only 2 5 or larger magnitude quakes for the past 24 hours, and it's time to get back to space. Space, where it's at, a frontier. These are the voyages of the SDO once again, another 24-hour video there. The house favorite wavelength, 171 angstroms, ionized iron. And by the way, thanks to everybody who's been leaving comments. We do get some great questions with respect to things like the chemical components in the corona and so on. More on that a little bit later in the video. Let's cut to a composite 24-hour video here. This is 211 angstroms added to add some fantastic detail to the corona. You can see coronal holes there, 3 of them, like a bowling ball style appearance there going on. And coronal holes are another important story to cover today. We'll get to that here momentarily. The 10.7 centimeter radial flux is now at 158 solar flux units, and we are expecting an uptick in this in the coming days as we've had sunspot growth, and a huge sunspot just rose in the southeast. So there is the 1-year graph of the radial flux. If you're not familiar with that, that is the solon.info image there, and that depicts the radial flux in black. The pink line is the 30-day sunspot average, and the red line is the sunspot number. The blue line is the AP index, which is an average of global geomagnetism, and guess what? We're expecting a spike in that. There is a CME, coronal mass ejection, likely to strike basically at any moment here. So we'll be monitoring that and sending out email alerts to people who have signed up for them at the Smash Team site. More on that toward the end of the video at the end of our meteorology segment. So there's the Space Weather Enthusiast dashboard. NOAA forecasting the onset of the coronal mass ejection impact to likely happen sometime in the next couple of hours here, around 1500 Universal Time. They're expecting geomagnetic unrest to start. Well, guess what? It's already started. And let's take a look at what's going on around the earthly environment here with our Geospace Magnetosphere movie. Yeah, Geospace Magnetosphere movie. So here are the past 4 hours of Earth's magnetic moment from space. That is depicting magnetohydrodynamic pressure, the units of which are nanopascals. And we're expecting a significant uptick here. The recent uptick that we've seen here was chiefly just from magnetic field changes. No major plasma impacts have even happened there. Just the magnetic field changing can create a lot of induction in the system. Here are the past 4 hours of Earth's magnetic moment from the ground over North America. We'll show the whole world map also, but we want to show this view, just to help familiarize our viewers with a great set of data to look at if you're expecting to maybe see the aurora in your location, if you've got clear skies, if this is showing major redness in your location. The telluric currents are likely high, and the likelihood of aurora may also accompany that. So that's our ground magnetic perturbations map for North America. We're also going to show the global map here after that resets. It's depicting geospace delta B, changes to Earth's B field. And of course, those are affected by the incoming solar plasma. So there is the past 4 hours in the global view. This will show you the most likely places to see pipeline induction, railway induction, power grid induction, the aurora, telluric currents at the ground level. Spikes on your ground-based magnetometer are likely to occur in those locations. By the way, if you want to monitor the grid, you can monitor the grid as the Smash News Network monitors the grid. And that's a great way to do it. The geoelectric field map. It shows actual induction into the power grid. And of course, the amount of induction into the power grid when a geomagnetic storm happens does depend on things like the composition of Earth's crust. As electricity flows through different materials differently, that is largely the reason why there are such huge variations, like that big stripe going down the east coast. That has to do with the conductivity of Earth's crust. So that is the geoelectric field map. It's literally showing induction in millivolts per kilometer It's showing power grid induction for US and Canada. So you can expect this to light up pretty well. And we are hoping that we are able to see the aurora here in Lehigh Valley, Pennsylvania, considered mid-latitudes. Currently, KP index already in geomagnetic unrest condition. How do you like them apples? Yeah, geomagnetic unrest already set in, and the CME hasn't even struck yet. It's just because of magnetic fields, which we will cover next. KP4 is the geomagnetic unrest condition, and you can expect this to go up to a possible KP 6.33. We're expecting it to come way up here, above a KP6. I wouldn't expect it to get to a KP7, though. Anyway, real-time solar wind is next. And this geomagnetic unrest situation was caused by this right here. So you can see the magnetic field, the vertical component, which is represented by this red line. It suddenly went into a strong negative signal that induces current into the Earth's system. It creates a pull of electrical current as opposed to a push with a strong positive BZ. And of course, the strength of the geomagnetic storm from the coronal mass ejection will depend not only on the plasma density and speed, but also the temperature, of course, and the magnetic field orientation. So that's what this top pane is. The white line is the total field. The red line is the vertical component known as the BZ. And that is the vertical orientation of that field. So at the moment, we have a strong negative BZ there. The total field is 8 nanotesla. The BZ is -6. Current solar wind density here, about 7.5 protons per cubic centimeter. Solar wind speed, about 500 kilometers per second. Again, we're expecting a significantly stronger signal than this. And if you look at the bottom there, you can see the blue and green lines switching. That is the switching between the ACE to the Discover. Currently on the Discover, represented by that blue line. GOES magnetometers here showing a little bit of sawtooth readings happening there. Not very surprising, as that magnetic field change has caused some variations in the GOES magnetometers readings. Those GOES satellites are located at about 23,500 miles of altitude. It's a geosynchronous near equatorial orbit for the GOES 16 and GOES 18. Next, perhaps the most important frame of the day. Yeah, even more important than the geomagnetic storm forecasts. And I want you to take a look at this right here. You see this? That is a coronal hole at the north heliographic polar region. It has now lurched down toward the equator. So once again, the floodgates are open for solar maximum, as that North Pole magnetism is eventually going to leave the north heliographic pole and not return for like 11 years. So that is one of the remaining features that needed to happen for us to get to solar maximum. And you can see that has indeed left and moved down toward the northwestern quadrant of the sun. There you can see in that latest image, there is now no North Pole magnetism at the north heliographic pole. That's a big deal, folks, as the coronal holes show us the solar cycle progression. So here's our line of sight field plot. And you're not seeing any major changes happening up there, but let's take a look at the coronal hole line of sight plot. That might make some differences. Let's see what we can see on that. Here's the line of sight coronal hole plot view, and you can indeed see that coronal hole moving down toward the mid-latitudes there. So again, that is a huge deal, and Earth is just about to move across a sector boundary crossing as well. So if you look at the last image here, the South Pole current sheet is also approaching. That should be here before we create tomorrow's daily space weather video. South Pole current sheet on the way. Floodgates open for solar maximum. It's exciting stuff, and we're delighted to bring you the most comprehensive daily space weather and detailed solar imagery you'll find in the known universe. So let's take a look at coronal holes here from our favorite wavelengths, the SDO 171 plus 211, and let's subtract the 171 to highlight those coronal hole features. And you can't really see the motion of that coronal hole movement very much. But it did indeed occur. The the polarimeters are not lying, folks. That has definitely moved. And again, that's a big deal. So this is a South Pole-oriented coronal hole over here. These are North Pole-oriented coronal holes. And the sector boundary crossing is looking like this. It will be here before tomorrow's daily space weather video. Let's get to sunspots next. There is the sunspot scenario. And okay, so 3364 got a name. 3363 will be reclassified as a Beta Gamma class sunspot group, as there is a North Pole umbra trailing it. There will be one new sunspot group at least today. This one down here in the south central portion of the solar disk. That'll be 3365. And let's move to look at sunspots here. So here we've put together 304 angstroms ionized helium plus the SDO HMI magnetogram. That is some sweet imagery indeed from the Solar Dynamics Observatory. Let's swap out the magnetogram for the SDO continuum. And then we'll subtract the ionized helium to show just the sunspots. And of course, keep an eye on this new group down here. And when I say ion, pardon the pun. And to that viewer that requested that we create some new merch, talking about we'll keep an eye on it, well, it's coming. Yeah, have you seen the merch shop? There's a link below the video to the merch shop. Check that out if you haven't. That's the past 24 hours from the SDO continuum. Some fantastic detail of the closest star and its sunspots, which we've put together for people just like you. So thanks for tuning in to the Smash News Network, least busted name of news. Let's switch to energetic particles next, as those are pretty exciting when they happen. At the moment, no energetic particles. Goes proton flux remains flatlined. The X-ray flux features one significant flare in the past 24 hours. Actually, there are two M-class flares there. This one's much more serious. It was an M3.9, and peak flux was at 6:30 this morning, universal time on 7/7. Now, if you want to monitor solar flares as they happen, a good way to do that would be to monitor the deabsorption region. What is it called? The deabsorption predictions, or DRAP. So this shows the attenuation of the ionosphere when it occurs. You know, people say, when is the solar flare going to hit the Earth? Well, the solar flare hits the Earth when the photons arrive, okay? Because solar flares should not be conflated to coronal mass ejections. They're a completely separate phenomenon. When the ionizing radiation, known as X-rays, show up, it attenuates that portion of the ionosphere, and it causes radio communications to careen into space instead of refracting back down toward the Earth level. So when you see this around 6:30, a radio signal which would normally bounce off the ionosphere or refract or get redirected from the ionosphere back down toward another target on Earth, instead of doing that, it goes right off into space. So that's one of the features here. Keep in mind, folks, that solar X-rays cannot be measured from the surface level. They are filtered out by the time they reach the stratosphere. So you've got to be at the mesosphere or higher to detect solar X-rays directly. But one of the features we can detect from the ground level would be the attenuation of the ionosphere. So that's what we show here. This is the radio blackouts, and it's showing you the different frequencies of radio blackout that occur there on the right side with those red bars. And the bigger the flare, the more frequencies are attenuated. So that's one way you can monitor the solar flaring in sort of a real-time respect. High-frequency radio blackouts caused by solar flares. You can also see solar energetic particle events here. They congregate around the poles. So here we've got your 131 angstroms wavelength from today. And there is that flare. And let's zoom that in a little bit and play that in slow-mo. So here's a great slow-mo from SDO. It was a quite impulsive flare there, not very long-lived. Should we bring up 94 angstroms as well? I think we could do that. And there's that M3.9 flare. Moving forward, there remains a high likelihood for solar flares, and let's talk about space. Yes, space. This is what's going on over our heads right now. And we are located in Lehigh Valley, Pennsylvania. You've got a setting moon and Saturn over there. And if you are up after dusk, go check out Venus and Mars very close together there, along with Regulus. Regulus and Mars very close together. So 3 objects visible there near the ecliptic: Venus, Mars, and Regulus, visible in the dusk sky. Now let's talk about space in a little bit more important ways. Yeah, space. The reason I've gotten involved in space weather, folks, is because of cosmology. So this is a field that I almost took up in earnest back in the mid-1990s. However, there was a lack of majors for that. And anyway, part of the reason why we cover the daily space weather is because, well, we've discovered some things that are pretty interesting indeed. And here's the most important science paper in probably hundreds of years: 40 lines of evidence for condensed matter. The Sun on Trial, Liquid Metallic Hydrogen as a Solar Building Block by Pierre-Marie Robitaille. Published all the way back in October of 2013. This paper proposes the possibility that stars are not indeed made of gaseous plasmas. And there are a lot of different lines of evidence in a lot of different branches of science that support this, whether it's the white light spectrum or countless other features. Anyway, there are hundreds of citations in this paper, and it has caused us to stumble upon the likely mechanism that underlies the solar sunspot cycles. So the limb darkening, the limb brightening, the reason why sunspots are dark, and lots of other features here. I won't sort of try to summarize it, but highly suggest you read the paper. The Sun on Trial, 40 lines of evidence supporting liquid metallic hydrogen as a solar building block. This is an increasingly important paper, and if reading the science paper is a little bit beyond your capabilities, don't worry. There's an alternative to that as well. Again, there are hundreds of notations in this paper and a lot of plausible explanations for stuff that is largely unexplained by cosmology. And of course, the implications of that paper on cosmology are super important, as when I first heard the theory, it hurt my brain real bad because, well, it will force a rewrite of cosmology. It's not because cosmologists are idiots and they've been doing stupid, idiotic work for all these years, gathering pointless information. It's not because gravity's fake or anything like that. The reason is because, well, this completely flies in the face of the concordance model of stellar evolution. And the concordance model of stellar evolution has all kinds of problems because we see stars and galaxies all across the universe that do not conform to this. In other words, how do you have a star that's older than the entire universe? That's just one of the many features that cause some people to start to come up with plausible solutions to major problems. So the implications here are very serious. Chemical reactions are completely sort of misunderstood or not understood at all when it comes to solar activity. And if you want this in more layman's terms, there is a great alternative for you. You can check our Amazon shop for that alternative. Right there, Alexander Unziker's book, The Liquid Sun, A Coming Revolution in Astrophysics. And it's very serious, folks, because the implications of condensed matter stars, well, let's just give one of them. One of the implications is that if stars are made of condensed matter instead of gaseous plasmas, they're actually much more stable than even mainstream astronomers believe. And they're about 10 trillion times more stable than people who think the universe is electric and stars are electric believe. So, yeah, The Liquid Sun, A Coming Revolution in Astrophysics is highly recommended. I haven't read it yet, but Alexander Unziker does have some valid points. Basically, this is just in order to sort of help explain the liquid metallic hydrogen theory of the sun, the LMH model, as it's called, to the layman. The Liquid Sun by Alexander Unziker. Again, you can find links below the video to the Amazon shop. You can even buy a shirt just like this one or glasses just like these via those links. Those would be in the spaceware section, not the books section. Next, we'll do a forecast for the solar system. And here's a forecast for Earth. People are going to get a lot smarter, a lot smarter. I know they've seemed like they've gotten dumber for the past 3 years, but don't worry, folks. That's just a little hiccup in evolution. Evolve or die. It's the only choice in the universe. So those are your choices. Please evolve, because the alternative is less than fortunate. Here's your 1 week forecast. We will have a crescent waning moon on July 14th. And let's move. Yeah, let's move to coronal mass ejections. So here are yesterday's frames. There was a CME late in the day yesterday, which you'll see right at the end of those 97 frames there. We'll also show today's frames to show the aftermath of that. It happened just an hour or two before midnight there. There are some additional frames. That is not an earthly directed coronal mass ejection by all accounts. However, don't take my word for it. Let's take a look at Soho-Lasco C3 as well. That depicted the C2 and some computer interpolation of it. Here's C3 alongside. That CME appears to be directed not toward Earth, but well off to the northeast. Next, we'll show stereo A also. We show this diagram to show its location. It's depicted by the red dot there, very close to the Earth, as it is overtaking the Earth as Earth and stereo B overtake each other. Here is stereo A on the left here. That's the stereo A Core 2 coronagraph. The stereo A coronagraph 2. And another indication that those CMEs are not likely earthly directed. Let's take a look at our custom coronagraphs, since we put those together daily to show you what's going on. Because, hey, folks, if you don't look, you're definitely not going to see it. You know, coronal mass ejections are part of what turned our channel off to the suspicious observers. Yeah, the suspicious observers. A lot of people think that's competition in the realm of space weather. And back in May of 2019, there was a little bit of a Facebook argument. We covered a coronal mass ejection right here in a video just like this one on our channel. And some hack fraud claimed that a CME never happened. That was when I realized that I'm not going to be gaslit, and that some people are utter hack frauds. Now, of course, that's not even to bring up the ridiculous hypotheses about cosmology. Significant CME happening there in the northwestern quadrant here, right at the end of our video. And that is likely a result of a CME there, also not earthly directed. I would suspect that it is, well, it could be, because we do see some motions happening in here, but I do suspect that it is from over here behind the limb, just from its location there. You'll see like a bright flash. All right, maybe not. Anyway, it is too early to really get a good understanding of what's going on with that one, so let's just move on here and take a look at filaments, since the likelihood of additional coronal mass ejection remains kind of high. So here is the ground-based solar observatory at El Teide, Spain. A lot of dark absorption features there. And some filaments there making their way out. So there's a CME, a couple of CMEs happening up here in the northeast. Those happened late in the day yesterday and early in the day today. That's your filament view. And by the way, if you don't follow us on Twitter, make sure you go follow us on Twitter. If you do social media, if not, we do not blame you, because the environment on social media is truly pathetic. Truly pathetic. And if you think Elon has fixed free speech and gotten rid of censorship on Twitter, please enter into the real world. You are living in a ridiculous fantasy. Here are the past couple of hours from the Agos 18 SUVI. And indeed, you can see indications of a CME happening from up here. So I suspect that is where that CME came from. We'll wait a few hours, and if it is going to be earthly relevant, especially if it's going to be headed toward Earth or anything like that, we will cover it. Because, well, that's what we do. And let's get to our bonus features segment. Bonus features are starting out with satellite charging hazards, and we've got some significant ones here of the surface charging variety over the eastern Pacific. So there you go, surface charging hazards there moving toward the central Pacific Ocean. That's low energy electrons building on the outside of spacecraft. Could cause some communications breakdowns. Here is the GOES electron flux over the past 3 days. And it was around where we forecasted for yesterday. You can expect it to get a lot lower today as the CME impact is almost here, folks. So there is the 1-year graph of the relativistic electrons, just to contextualize that. And here is the NOAA forecast model. So I believe that was right around where I forecasted yesterday. The next one will be even lower here. So I'm surprised that NOAA's not forecasting a big dip in the electron flux. We'll have to see what happens. The green boxes are the forecast, the yellow diamonds are the observation. And next we'll show the F layer of the ionosphere, because that's where those electrons are measured. And of course, this can also show us other features, so we like to show it daily on the channel. That's the past day in vibrational frequency. And we may see some, I am expecting to see some low frequency anomalies happening here because, well, we did get into geomagnetic unrest conditions because of the magnetic fields we talked about earlier in the video. So let's let that play through to the latest image here and then show the anomalygram, which is going to show a lot of red. Although it's going to show even more red when the coronal mass ejection strikes in earnest. So there's your anomalygram. That's anomaly in megahertz from a 30-day median. You can expect this to be even more interesting looking in tomorrow's daily space weather video, as we show all the information and we have zero bias. We approach the science from a good faith perspective. Here is July 7th at 12:30 Universal Time. There's the ionogram, and there is the anomalygram. And as you may have expected, some low frequency anomalies there showing up in both hemispheres. We'll also show the total electron content, which is also showing some significant anomalies. Feel free to pause the frame on this. Feel free to pause the video on this frame if you're not familiar with the distances to those things in miles. So here you can see some major electron content anomalies. It depicts free electrons from your GPS satellite down to your handset. The coupled thermosphere, ionosphere, plasmasphere electrodynamics model will show you the most likely places to see GPS errors, and you can see some huge anomalies there in the southern hemisphere, the southern Indian Ocean, Southern Ocean, Antarctica, and the southern Atlantic especially, showing some anomalously high electron contents, some perhaps unlikely areas for GPS errors. Here's the Anomalygram, that's the anomaly from the 10-day average for the total electron content over just North America. And only some low electron content anomalies showing up there. Things are pretty normal otherwise. We'll also show the latest intensity gram. And we show the refresh just so you know. Here is the latest huge sunspot. And you can see that trailing umbra there. There is a North Pole umbra behind that sunspot, making it a beta gamma class sunspot, making it more likely to produce a large flare. Also, this spot down here is a beta gamma sunspot. This one up here is a beta gamma sunspot as well. So there still is a significant probability for large solar flares. And the most likely candidates would be this area here and this area here. And there's a close-up of the magnetic environment. There are some deltas there with those beta gamma class sunspot groups, and some deltas there as well. There's a close-up of that. And there's a close-up of those several sunspot groups. The recent M3.9 flare came from this group right here. So that is the space weather section of the video. And by the way, congratulations on realizing the Smash News Network least busted name in news exists. We're frankly surprised that you've found the channel with the pathetic and putrid state of censorship on the internet right now. It's completely broken. And of course, some of the largest crime syndicates in human history are attempting to destroy information itself on the regs. So let's provide some more, as we're discouraged for putting out more videos. And guess what we do? We put out more videos instead of less. So here is the sea surface temperature and wind. The animation depicts the surface wind environment, and the shading depicts sea surface temperature anomaly. Just to, maybe I'm beating a dead horse here, but there is no grand solar minimum happening. And not only that, if you're expecting a year without a summer in Europe, you are living in a fantasy world. Look at how warm the ocean is. Look at how warm the Mediterranean is. Look at how warm the North Sea is. It is simply not a grand solar minimum. And if you're waiting for the AMOC to shut down, the Atlantic Meridional Overturning Circulation, that's not happening either. The Gulf Stream is making it up to Ireland and Iceland just fine. Here are the currents. And there you can see that water motion, the Gulf Stream there, looking just fine. If you're banking on a year without a summer, you've done some bad banking. Get a different bank. Here are the rest of the sea surface temperature anomalies. There's the Pacific. There's the Southern Ocean. Here's the Atlantic. And there is the Indian Ocean. Last but not least, there is the Arctic. And let's switch to the regularly scheduled meteorology segment. So here are the surface winds of the central world. That's Africa, Europe, and the Middle East. A strong offshore wind there at South Africa could make some great surf conditions if you're not eaten by a shark. Here are the jet streams of the central world. A huge kink there over the African Rift Zone. Northwest of Madagascar. Here are the jet streams of the eastern portion of the planet. And if you're located in this area, especially, please share the videos, as we are not satisfied with the number of views or subscribers on the channel. Space weather, it applies to everybody on the whole planet. Here are the surface winds of the east. Here are the surface winds of the west. And here are the jet streams. Pretty decent jet stream here over the U.S. at the moment. We'll show you forecasts on that a little bit later. Let's take a look at soil moisture and droughts. So here is this is the moisture anomaly at the moment. It's quite moist there in places like Kansas and Nebraska. It's also quite dry in places like Wisconsin and the coastal portions of Oregon and Washington. Here's your drought intensity map. And most of the drought in the central part of the country has subsided. It's been way too hot and I guess kind of dry in the Pacific Northwest there. Check out Vancouver Island, very, very dry, making for some great mountain biking conditions, I would suspect. British Columbia, some of the best mountain bike riding in the world. That's your drought intensity map. Here's your raw soil moisture map if you're wondering about that. And there's your moisture anomaly map, once again, from windy.com. Next, we'll show the clouds and fog scenario over the Americas. So that's what's going on from the NASA GOES Interactive Weather Satellite 3.9 micrometer infrared radiation map. It shows clouds and fog at nighttime, and yes, you can use this if the aurora are likely visible at your location to see if it's cloudy where you are. You could also just simply go outside and see if you see stars, but if you're that lazy that you'd prefer to look at this, the NASA GOES Interactive Weather Satellite 3.9 micrometer infrared radiation map, the shortwave radiation, will show you the likely places to see clouds and fog. And here's your weather.gov map. We'll briefly scroll down to show you the key. We've got some red flag warnings and some serious weather there in Kansas and Oklahoma. Hopefully nobody is in Oz right now. And let us know if you're viewing the video from Oz, a separate plane of existence, universe, multiverse, planet, solar system, starship, timeline, etc. Here comes some forecasts. This is your temperature anomaly forecast in degrees Celsius based on the 72-hour GFS model. Most of the central country there remaining on the cool side of things. And west of the Rockies, mostly on the hot side of things, but some wild temperature gradations there. That's the 72-hour GFS temperature anomaly forecast in degrees Celsius. Here is the jet stream forecast. It's the 250 millibar wind speed. Based on the same model, the GFS 72-hour. And we'll have a fairly coherent jet stream there, making weather forecasting a little bit more straightforward. And last but not least, here is pressure and precipitation based on the same model, the GFS 72-hour. So some heavy storms there coming to the mid-Atlantic states, including us, in the next couple of days. They're about 3 days out. Eastern Pennsylvania and New Jersey are going to get hit pretty hard, especially the northern part of Jersey. Also, you can see the forecast there for the central U.S., some major storms that are coming to Kansas, Oklahoma, Arkansas, etc. That's a 72-hour GFS pressure and precipitation forecast. Here is your lightning mapper. That's what's going on currently. That's the past 10 hours. And there is something going on currently, a major storm here moving across Oklahoma. So just north of Oklahoma City there is certainly thunder rolling in here at the moment. We won't show that for too long since this video wasn't live streamed. This was a recorded video. We've stopped live streaming because of, well, reliability. Lightningmaps.org is where to get your real-time lightning map. That's where the cells were when we recorded this video. And, you know, on a related note, these videos are extremely expensive. Yeah, they're extremely expensive. So project management facts are what this product is. You can get it in all kinds of different designs because these videos are right here. They're good, they're fast, and they're not cheap. Because producing the amount of content that we produce at the level that we produce it so consistently for 6 years is extremely expensive. So if you want to support the channel, one of the ways you can do it is by picking up merch. It does have our website down there at the bottom in the lower right. And if you're a project manager who thinks the project can be good, fast, and cheap, you are a hack fraud project manager, and you should take this to heart because your project can't be good, fast, and cheap, so pick two. It can either be fast and cheap, in which case it's not going to be good. Please avoid that at all costs. It can be good and cheap, in which case it'll be slow. Maybe you have a contractor friend who's willing to work on your stuff for free and only charge you for materials and things like that. He's probably not going to do it fast, though. So it's going to be good and cheap, but not fast. See what I'm getting at here? These videos are good and fast, but not cheap. So please support the channel via merch. Start a conversation with your friends and foes. Maybe send your favorite project manager a t-shirt or a sticker or maybe a poster to hang on their office wall to reinforce this basic fact of the universe. Just like evolve or die, it's not going to be fast, cheap, and good. So pick two. It can either be good and fast but not cheap. It can be good and cheap but not fast, or the worst of all, it can be fast and cheap but not good. And if you're in that portion, please either make the job better. Please make the job good. So get into either the space of 1 or 2 and get out of 3. Expensive or slow, not bad. Bad is not good. You can also support the channel via subscription services at the Smash Team site. We do send out email notifications about things like space weather alerts, tsunamis often before USGS sends them. We also evaluate those alerts. We send out alerts just like for videos just like this one. So for everybody complaining about not getting YouTube notifications, just sign up for email alerts at the Smash Team site. You can get those for the gold level at $0 per month. There's a silver level and a gold level as well, which gives you additional content. Links at the Smash Team site. And welcome to the Renaissance. SmashOmash.com is our homepage. And by the way, we are on Threads for Instagram. It's yet another social media site that is just great. We're so excited, folks. We're so excited. Follow us on Instagram if you like for diet and fitness type tips. Let's close this thing out with some more current weather data. So there's the U.S. situation. We've got strong storms here moving into Iowa and across Oklahoma at the moment. We will focus on the lower 48. There is clouds and fog. By the way, if you think this 1,000-mile-long cloud is a chemtrail, you do not understand atmospheric physics. There is a pressure gradient there, which you'll be able to see easily on the water vapor map. And there you can see a huge pressure gradient. Gee, isn't that a surprise? So anyway, clouds forming there as that dry mass of air is unable to be supported by the warmer, moister air to its south, causing clouds to form, causing the relative humidity to be 100%. Anyway, here's your recap. U.S. Doppler radar, that's ground-based systems detecting vertical motion in the air column. Here's a satellite-based system depicting shortwave radiation, part of the infrared spectra. And here's the water vapor map depicting a different portion of the infrared spectra. That would be 6.19 micrometers. Showing water vapor, all of it, including dry skies, as well as moist. Anyway, we hope you're not too moist over the incoming space weather. We hope you haven't slid off of your chair as a result of this. Anyway, since I'm very spooked of space, I've been watching a lot of nonsense on YouTube about it and doing market research into space weather content. And so I've found a lot of nonsense. We're hoping you're avoiding said nonsense. And in the meantime, we may make another video today because, geomagnetic storm. So, but in the meantime, I'm headed back to the bunker because I am spooked of space. So spooked. And while I'm gone, may that solar wind be at your back. Stop your grinning and drop your linen. I'm going back to the bunker again. Whoa!